Formation of fireworks by Bandesha, grade 5, Martindale, Hulka, Calgary. Table of contents. Introduction. Purpose of the flame test. The purpose of the flame test is to observe how different metals change colors when exposed to heat. Then this will increase my knowledge in the study of elements and chemistry. Different colors are produced when electrons are very excited and move to other valence. When they're relaxed, they change colors as they move back to the inner ring. This can help me identify metals because the number of electrons will affect the color change. Chemical formulas. These are the chemical formulas I will be using for the film test. Sodium carbonate, copper chloride, lithium chloride, potassium chloride, calcium chloride. This is a diagram of a firework. This is the bursting charge. This is the black powder, and these are the stars. Method. Manipulated variables. Types of metal we burned. Closeness to blowtorch. Responding variable. The color of the flame. The control variables. Constant environmental each time, and equipment, such as blowtorch, clear metal plates, and Q-tips. Hypothesis. What I predict will happen. If the metal is less reactive, then its color will be closer to a blue spectrum because of the number of electrons in the outermost shell of the atom. That determines its reactivity. Therefore, it's less reactive. The metal has more room to accommodate the temporary electrons. If the metal is more reactive, the color will be nearer to a red spectrum because the outer shell has less room to accommodate the temporarily electrons. For example, copper will be greenish blue, and potassium, calcium, sodium, and lithium will be all near the orange side. Experiment. The flame test. This is a chart of the flame test that we did. This is the compound, the chemical formation, the metal ion that's present in front of you, and the flame color, the behavior, what it did, how it reacted to the flame. Compound, sodium carbonate. It was bright orange and burned a little, and it was somewhat reactive. Copper chloride. I observed and I figured out it was greenish blue, and it took longer to burn than the sodium. I figured out translation metals are less reactive than alkyne metals such as sodium, and it was catalytic. Lithium chloride. The color changed to a red. It burned very quickly. Along with the other alkynes, earth metals, they are very reactive to the flames. Potassium chloride. The color was an orange and a hint of purple at the bottom, and it took longer to burn. Calcium chloride. It was orange and it moderately burned. This is photos of the experiment, the flame test. Sodium, calcium, and potassium were all near the orange side of it, phase. Lithium chloride was more of a blue phase, and copper chloride, but it burned red, and copper burned like a greenish blue color. Reflection. The periodic table groups affect the element's reactivity, which affects the color of the flame in our experiment. The nonmetals are not very reactive, which is why they would have dimmed the light or the flame. Alkaline earth metals are highly reactive, and since these include lithium, potassium, and calcium, these three tests were all on the orange spectrum. Copper is a translation metal and is less reactive to sodium, which is an alkaline metal. As you can see from my observation, the reactivity in periodic table groups affects the response of a variable, which is the color vary among the wavelength spectrum. I found the results online. Sodium was more of a yellow color in the middle when it was added to the flame. It was muted when sodium salts are placed in a blue flame. Sodium yellow also overwhelms other colors. Copper, depending on its state, copper can vary from green to blue or even both. Copper 2 produces a green flame, while copper 1 produces a blue flame. If there's some copper 2 present, you'll get a green-blue flame. The compound is often confused with boron, which also produces a similar green flame. Lithium yields a flame test between red and purple. It is possible that you might get a pink